Let me read the question now. For the question 10 part A, a school bookstore is having a stock clearance promotion which involves 8 different pens and 10 different notebooks. NV will spend 24 ringgit in the promotion. Table 1 shows the price for a unit of each item. Okay, so as you can see in the table over here, the price for one pen is 2 ringgit, whereas the price for one notebook is actually 4 ringgit. Okay, so continue to read the question. Find the number of different ways NV can buy the item if she wants to buy notebook only. That's for the part 1. For the part 2, the number of notebooks is at most equal to the number of pens. Okay, so this is the question 10 part A. So let me read the question 10 part B now. Let me read the question 10 part B now. Diagram 6 shows an example of 5-character password formed by using letters and digits 5, 4, 3, 2, 1. Let me read the question 10 part B now. Diagram 6 shows an example of 5-character password formed by using letters and digits on a computer screen. So as you can see here you have capital letter E, capital letter N, 7, E and 4. Okay, so continue to read the question. Find the number of different passwords if the first 3 characters are capital letter A, 8, small letter a without repetition. The first character must be a non-vowel capital letter and followed by at least 2 prime numbers placed adjacently. Okay, so this is for the question part B, guys. Okay, question 10 part B. So we have gone through part A and part B questions. Okay, so take your time to solve these 2 questions and we will begin the discussion in a count of 5, 4, 3, 2, 1. Let us begin our discussion for the question 10A part 1, where they ask us to find the number of different ways NV can buy the item if she wants to buy notebooks only. Okay, before you begin this question, I want you to identify whether this question is asking for a permutation concept or a combination concept. Okay, by the end of you reading this whole question part A, you should come to a conclusion that this question is actually asking for a combination concept. Okay, how to know? It's actually very simple. If a question is actually emphasizing arrangement, that means that particular concept is actually asking for permutation. Otherwise, it is a combination. Okay, in this case, they're asking for the number of ways NV can buy if she wants to buy notebooks only. For the part 2, they're asking us the number of notebooks is at most equal to the number of pens. Okay, so let us solve for the part 1 first, and once we're done with the part 1, let us move on to the part 2. Okay, since NV wants to buy notebooks only, okay, so how many notebooks we have? We have 10 notebooks, and price of one notebook is actually 4 ringgit. And do take note, guys, NV's budget is actually 24 ringgit. Okay, so before I begin, let me write in the working here. Okay, so budget in this case allocated by NV is 24 ringgit. Okay, and then price of one notebook is actually 4 ringgit. Okay, RM4. So from here, how to get the combination? Very simple, guys. So 24 ringgit, you divide with 4 ringgit, you'll get the number of notebooks NV can buy. So from here, so hence equals to RM24 divide with RM4. So from here equals to 6 notebooks. Okay, okay, so from here we have 10 notebooks and we get to choose only 6 notebooks. Okay, so from here we can calculate our number of ways to buy notebook. So from here, number of ways to buy notebook is equals to, so from here out of 10 you choose 6. Okay, so from here, okay, let us calculate together. Okay, out of 10 choose 6, you get your answer is 210. Okay, it's very straightforward. So let me underline this. Okay, so that's all guys, we're done with the part 1. Okay, let us move on to the part 2, where they ask us to find the number of different ways and we can buy the item if the number of notebooks is at most equal to the number of pens. Look at the keyword guys, from here they mentioned at most equal. Okay, number of notebooks at most equal to the number of pens. Okay, so from here what it actually means that your number of notebooks should be less than equal to number of pen. Okay, so from here let us write our working here. So from here NB, so N subscript B, so it's denoted as notebook. So from here NB should be less than equals to P. Okay, small letter P, okay, which denote as pen. Okay, so from here you have 10 notebook and you have 8 pen. Okay, and this condition you have to fulfill, where you have your number of notebooks should be less and equal to number of pen. Okay, in this case. And let me remind you again that Envy's budget is 24 ringgit. So whatever combination you have, you must fulfill the budget guys. Okay, the budget in this case is 24 ringgit. Okay, so from here how to come up with the combination, possible combination? Okay, very simple. So from here we know that number of notebooks should be less than equals to number of pen. So we start with the possible of the highest value over here, which is the number of pen is actually 8. Okay, so from here we can have our possible case 1, where we have 2 notebook okay, and 8 pen. Okay, I'm sure you guys wondering why I'm choosing pen, right? Okay, pen is actually very straightforward over here guys. Okay, 8 times with 2 ringgit you get 16 ringgit. Okay, and then 24 you minus with 16, how much you left? 8. So 8 you divide with the price of 1 notebook, which is 4. So 8 divided by 4, you get 2. So that's how I come up with the combination of 2 notebook plus with 8 pen. Okay, let me show you one more time guys. Okay, so from here you start with one item. Okay, in this case I recommend you to try with the pen. Okay, so from here 8 times with 2, okay, 16. So from here your total budget is 24. So 24 minus with 16, you left with 8 ringgit. And remember, price of 1 notebook is actually 4 ringgit. So from here 8 divided with 4, you get is 2. So that's how I get here the 2 notebook plus with 8 pen combination. Okay, so this is the statement, mathematical statement, and then you convert it into an equation form. And it's fulfill the budget also guys, because 2 times with 4, okay, 2 notebook times with 4 ringgit plus with 8 pen times with 2 ringgit. Okay, you calculate this, 2 times 4 you get 8, 8 times 2 is 16. Okay, 8 plus 16 you get is 24 ringgit. So from here, so this statement we need to convert into an equation form. So how are we going to do that? Okay, very simple. So how many notebooks we have? 10. So out of 10 we are actually choosing 2 notebooks. Okay, and since we have a plus n, okay, 2 notebook n guys, okay, it would be appropriate if I use the n symbol. Okay, if I use the plus symbol, I'm afraid that you might get confused between the and or statement. Okay, 2 notebook and 8 pen. Okay, so 2 notebook and 8 pen. So when you have an n, that means that you need to multiply. Okay, 8 pen. How many pen you have? 8 pen. So out of 8, okay, you get to choose 8 pen. Okay, so from here, calculate this. So 10 C2 times with 8 C8. So you get your answer is 45. Okay. So this is your case 1. Okay, so let us move on to the case 2. Okay, we have begin with the 8 number of pen. So let us try with the 7 number of pens now. Okay, 7 number of pen. 7 times with 2, you get 14. Okay, 24, the total budget you minus with 14, you get is 10. Price of one notebook is actually 4 ringgit, so it doesn't tally. Okay, so in this case, odd numbers doesn't apply, guys. So you need to have an even number in this case. So since we can't use the number 7, okay, we're going to use it number 6. Okay, 6 number of pens. Okay, so from here 6 times with 2, okay, you get 12 ringgit. So 24 minus 12, you get 12. Okay, so from here price of one notebook is 4 ringgit. So 12 divided by 4, you get this 3. So our second case will be 3 notebook and 6 pen in this case. 3 notebook and 6 pen. Okay, so you can check whether it's tally with the budget or not. Okay, so from here 3 times with 4, okay, you get is 12. Okay, and then plus with 6 times with 2, you also get 12. 12 plus with 12, you get is 24 ringgit. Okay, so from here, out of 10 notebook, you're choosing 3. So 10 C3, okay, times with, out of 8 pen, you're choosing 6. Okay, so from here, 10 C3 times with 8 C6. You calculate this, you get 3360. 3,360 number of ways. Okay, so this is your case 2. Okay, let me remind you again, guys, your number of notebook must be less than equal to number of pen. Okay, that means it can be same. Your number of notebook can be as same as number of pen. So that means we still have one more case left, okay, which is case 3 in this case. So case 3, okay, we can have 4 pen. Okay, we cannot obey the odd number, so we can use the even number in this case. So from here, 4 times with 2, okay, you get is 8. So 24 minus 8, you get is 16. So from here, 16 divided by 4, you get is 4. So in this case, you will be having 4 notebook and 4 pen for third case. Okay, so from here, your case 3 will be 4 notebook and 4 pen. Okay, you can even check this. Okay, so from here, 4 times with 4 plus with 4 times with 2. So 16 plus with 8. So from here, you get is 24 ringgit. Okay, 24 ringgit. Okay, so from here, out of 10 notebook, you get to choose 4. Okay, and then times with, since you have the n, okay, times with, out of the 8 pen, you are choosing 4. Okay, you calculate this. So from here, 10 C4 times with 8 C4, 14,700 ways. Okay, so from here, total ways. Okay, our final answer will be case 1 plus with case 2 plus with case 3 value. Okay, so from here, $45 plus with 3,360 plus with 14,700. So from here you get your answer is 18,105. So this is your final answer, guys. Okay. So that is all for the question 10 part A. So let us move on to our discussion for the question 10 part B now. Let us proceed our discussion for the question 10b and begin our discussion for the part 1, where they ask us to find the number of different passwords if the first three characters are capital letter A, number 8, small letter a without repetition. Okay, by the time you finish read this question 10b, you will have some idea that this question is actually asking for a permutation question, because as you can see that it is actually showing an example of 5 character password formed by using letters and digits on a computer screen. Okay, password is actually a case sensitive, guys. Okay, hence we can conclude that this question is actually asking for a permutation concept. Okay, so from here, this diagram 6 is actually one of the example of a password, guys. Okay, password means that, okay, let's say you have this diagram 6, you cannot have the same type of password repeated again. So each password is actually unique. That's why I'm saying it is a case sensitive. Okay, so from here, let us begin our discussion. Before begin our discussion for the question 10b part 1, okay, you need to know the number of small letters, number of capital letters, and number of digits from 0 to 9. Okay, by having this information, it will be useful for us to find the number of arrangements of the password. Okay, for the part 1 question. Okay, let us begin. So from here, so we need to know the number of small letters. Okay, the number of small letters is actually very simple. Okay, you just need to calculate the A until Z. So you calculate A, B, C, D up until Z, you'll have 26 letters. Okay, all of the small letter. Okay, when you're creating a password, you don't only consider having a small letter, you'll have capital letter also, right? So you need to have number of capital letter, number of capital letter. Okay, it is actually same as well, 26. Okay, A until Z, all capital letter, is same as the number of small letter, 26. Okay, and then we need to calculate the number of digits from 0 to 9. Okay, 0 to 9, when you calculate 0, 1, 2 up until 9, you'll get is 10. So 26 plus with 26, and then you plus with 10, you get a total of 62. Okay, why I write here 62? Okay, later I'll explain to you. Okay, so now jump into our question. Okay, we need to come up with the 5 character password. So let me draw here 5 spaces. Okay, 1, 2, 3, 4, and 5. Okay, for the first 3 position, they already gave us the condition that it must be capital letter A for the first position, number 8 for the second one, and small letter a for the third one. Okay, since these 3 are fixed, technically they can only have one possibility, which is 1 respectively. Okay, for the fourth position, okay, you need to minus with these 3 numbers, guys. Okay, 62 minus with 3. Okay, why 3? Okay, take a look at the question carefully. They mentioned that the first 3 characters without repetition. Okay, first 3 characters of capital letter A, number 8, and small letter a without repetition. Without repetition means once you place in the capital letter A here, that's it. You cannot use it anymore. Okay, so that means that you need to minus 1 over here. So 62 you minus 1 over here, you get is 61. Okay, and then number 8 you already used already, so minus some more, you left with 60. And you already used the small letter a over here for the third position, minus some more. So for the fourth position, your possibilities of having letters, capital letters, or digits will be 59. Okay, very simple guys. 62 minus 3 you have is 59. Okay, this is for the fourth position. Okay, and same as well guys, since it is without repetition, okay, for the fifth position it will be reduced by 1. So you will have 58 in this case, because the question mentioned us is without repetition. So from here we already have the possibilities, so we can calculate our number of different password. So from here we can calculate that the number of different password is equals to 1 times with 1 times with 1 times with 59 times with 58. Okay, you calculate this. Okay, so from here you have to calculate 59 times with 58. So from here you get your answer is 3422. So this is your number of different password that you can form by having these three conditions. Okay, so 3422. So this is your answer for the question 10b part 1. So I hope you guys are clear about this regarding this explanation. Okay, so we already done with the question B part 1. Let us proceed our discussion for the question B part 2. Okay, for the question B part 2 is going to be slightly tricky. Okay, let me read the question now. They mentioned that the first character must be a non-vowel capital letter and followed by at least 2 prime numbers placed adjacently. Okay, so read the question carefully. If you're not sure, to be safe, just write the condition given by the question over here. Okay, just write in your working here. Okay, condition, first character must be a non-vowel capital letter and followed by at least 2 prime numbers placed adjacently. Okay, so let me read the condition again. The first character must be a non-vowel capital letter and followed by at least 2 prime numbers placed adjacently. Okay, let's break down one by one. First character must be a non-vowel. Okay, non-vowel, in this case they are saying that it must be a capital consonant letter. So in order for you to identify how many consonants you have, you need to know the number of vowels you have in the letter. Okay, vowel is actually A, E, I, O, U. Okay, so A, E, I, O, U, you have total of 5 vowels. The total letters you have from A to Z is actually 26. So to calculate the number of non-vowel capital letter will be 26, you minus with 5, so from here you get 21. Okay, so that is the first information that you need to write in your working. So number of non-vowel capital letter, okay, in this case is equals to total number of letters 26, and then you minus with the number of vowels. Okay, so 26 minus 5, you get total of 21. This is actually 21 consonants capital letter. Okay, so from here we already got the first information. Let us proceed to the second information. Is actually they need to ask us to find prime numbers from 0 to 9. Okay, prime number is actually a number that can only be divided by itself and also by 1. Okay, so from here number of primer should be prime number from 0 to 9. Okay, you need to list them out. So from 0 to 9 you have 2, 3, 5 and also 7. Okay, so you have total of 4 prime numbers. Okay, so I hope you guys are clear about these two information. You have the information of non-vowel capital letter and you already have the number of prime numbers from 0 to 9. You have total of 4 prime numbers, which in this case will be 2, 3, 5, 7. Okay, by the way, you can ask me, sir, why didn't put 1 as a prime number? Okay, technically 1 cannot be a prime number because in order for you to have a prime number, you must have at least 2 factors. 1 has only 1 factor, okay, hence it cannot be a prime number. Okay, simple explanation, guys. Okay, hence you only have your prime number start with 2 followed by 3, 5, 7. Okay, so let us proceed our discussion. So from here what you're going to do is we're going to build case by case, guys. Okay, let us begin with the case 1. Okay, so from here pay attention carefully, guys, because I'm going to explain you one by one. So from here C1, okay, I'm going to write in a short form. So from here our case 1 will be, okay, our first character, okay, I'll write here NVC. Okay, we have non-vowel capital letter and 2 prime numbers side by side. Okay, because they say us must be at least 2 prime numbers placed adjacently, guys. Okay, so technically we can have about 3 cases. Okay, this is your case 1. Your second case will be your first letter non-vowel capital letter and followed by 3 prime numbers side by side. And your third case will be first letter, you have a non-vowel capital letter and followed by 4 prime numbers adjacently side by side. Okay, so let us begin with the case 1. Okay, let me draw the 5 characters. Okay, 5 spaces over here, 1, 2, 3, 4 and 5. Okay, and before I begin the discussion further, okay, this question they didn't mention any specific condition of without repetition. So technically for the part 2, the repetition law applies over here, guys. That means numbers can be repeated, the letters can be repeated. Okay, so from here for the case 1, you place a non-vowel consonant over here, okay, NVC. Okay, so the total of non-vowel capital letter you have is 21. So that's why over here you have 21 outcomes in your first character. Okay, so pay attention carefully. In your first character, okay, you're placing a non-vowel capital letter. So how many non-vowel capital letter you have? You have 21. Okay, just now we have calculated, right? So that's why you place the 21 outcomes over here. Okay, we're done with the first character. For the second one, okay, you need to followed by at least 2 prime numbers placed adjacently. Okay, that's why you have the case 1 over here. So we're going to write here PN. Okay, PN short form for prime number. Okay, and also prime number over here. Okay, so how many prime numbers we have? 2, 3, 5, 7. Okay, so you have 4 outcomes. Okay, for the third characters, how many outcome that you can place in your third character? Also same, 4. From here, okay, this is where the trick comes in, guys. For your fourth character, how many possibilities you think you will have over here? Okay, so technically for this case you need to exclude your prime numbers. The 4 prime numbers you cannot place over here. If you place the 4 prime numbers over here, so it will be considered as the third case. You need to be careful, guys. It's not going to be 62, but then it's going to be 58 outcomes. Because this is actually a case 1, you need to have only 2 prime numbers placed adjacently. So for the fourth character, you need to exclude the prime number. So 62 minus with 4, so that's why you have 58 outcomes over here for the fourth character only. Okay, come for the fifth character. Okay, so how many outcomes you can have in the fifth character? You can have 62, guys. Okay, so you can have actually 62 possibilities. You can have all number of small letters, all the capital letters, and all numbers from 0 to 9, including the prime number, because this is the rule they mentioned. It must be a non-vowel capital letter and followed by at least 2 prime numbers. Okay, so if you place any prime numbers over here, it will be considered as a case 2. So that's why you need to exclude the prime number for the case 1 only, guys. Okay, that's why 62 minus 4, you get 58. And for the fifth character, you can have all the possibilities. That's why you have here 62. Okay, so from here, so for the case 1, you calculate everything. So from here, 21 times with 4 times with 4 times with 58 times with 62. So you calculate the number of arrangement for case 1. 21 times with 4 times with 4 times with 58 times with 62. Okay, 1,208,256. 1,208,256. So this is your case 1. Okay, move on to the case 2. Okay, case 2, you have first letter of non-vowel capital letter, your first character, and followed by 3 prime numbers placed adjacently. Okay, so from here, let me draw the 5 spaces. Okay, so from here, the first character followed by non-vowel capital letter, okay, is the same. You have 21 possibilities. Okay, and then followed by 3 prime numbers. Why 3? Take a note at the keyword, guys. At least. At least means at least 2 prime numbers. You can have more than 2 also, right? So that's why we are following the condition here. Prime number, and also prime number. Okay, how many possibilities you can have in the second character? You can have 4. Here also you can have 4. Here also you can have 4. Okay, so from here, for the fifth character, you cannot have a prime number over here. If you place a prime number over here, it will be a case 3. So you need to exclude the prime number in this case. So 62 minus with 4, you can have 58 outcomes. Okay, so from here, you calculate number of arrangement for case 2. So from here, 21 times with 4 times with 4 times with 4 times with 58. So from here, you get your number of arrangement. (21) times with 4 times with 4 times with 4 times with 58. 77,952. Okay, this is for the case 2. For the case 3, okay, it will be first character of vowel capital letter and followed by 4 prime number. Okay, so let me draw the 5 spaces. Non-vowel capital letter. Okay, and this time you place all the 4 prime numbers adjacently. Okay, so from here, the number of outcomes will be 21. Here will be 4. Here will be 4. Here will be 4. Here also will be 4. Okay, the number of prime number outcomes, guys. Okay, since we are repeating, so everything will be same. So from here, it will be 21 times with 4 times with 4 times with 4 times with 4. So from here, you get your answer. 5,376. Okay, so total arrangement will be equals to 1,208,256 plus with 77,952 plus with 5,376, which means case 1 plus with case 2 plus with case 3 plus all of them. Okay, you get your answer is 1,291,584. So this is your final answer. Okay. So we have come to the end of the discussion of SPM 2022 at Maths Paper 1 question number 10. I hope you find this video useful. If you like this video, make sure that you click the like button and subscribe to the channel for more upcoming Maths tutorial videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.